So guys, this is session number 2 on linear and quadratic expressions. So I will be taking few problems. Uh, so in session number 1, it was linear upon root of quadratic. In the first session, it was linear upon quadratic. This was session number 1. In session number 2, it is linear upon root quadratic. So this becomes session number 2. Okay, so I'll take some problems which will help you to understand the topic better. Yeah, so let me just pull out some problems from the textbook. Just a second. Uh, yeah. So the first problem that I'm going to take up is something like this. Integration of 6x plus 7 upon root of x minus 5, x minus 4 dx. Okay, now see, we'll multiply the two brackets within the root in the denominator. So this becomes x square minus 5x minus 4x, that is minus 9x plus 20 dx. So this is linear term upon root of quadratic term. Linear because the derivative of, linear because the power of, maximum power of x in the numerator is 1. Okay. And root of quadratic. Under root there is a quadratic term. So same way we'll proceed. Numerator, or let's say linear, is equal to a d by dx of quadratic plus b. So 6x plus 7, a d by dx of quadratic. Quadratic is x square plus 9x plus 20 plus b. Right? So now what we will do is x square minus 9x plus 20, we are going to derivate this. So this will be 6x plus 7 a into 2x minus 9 plus b. So immediately after the derivative, whatever step we get, that is step number 2. We derivated, we got 2x minus 9. So this becomes step number 2. Now just open the brackets on the right hand side. So 2ax minus 9a plus b. So by comparing, if you recollect the previous session, it was the same thing. Compare the x terms, the coefficient of x terms. So 6 is equal to 2a, a is equal to 3. And compare the non-x terms. So 7 is equal to minus 9 a plus b, minus 9 into 3 plus b. So 7 is equal to minus 27 plus b. So b is equal to 34. Okay. B is equal to 34. So we got the values of a and b. Now we are going to put these values of a and b in equation number 2. So the next step is put ab in equation number 2. So equation number 2 is 6x plus 7, 3 into 2x minus 9, plus b. B is 34. Okay. So from 1, take a look at equation number 1, which I'll show you right now. We got the value of 6x plus 7. So the value of 6x plus 7 is 3 into 2x minus 9 plus 34. So 3 into 2x minus 9 plus 34 upon root of x square minus 9x plus 20 dx. Now split this into two parts because there is a plus sign in the numerator in between the two terms. I is equal to 3 into 2x minus 9 upon root of x square minus 9x plus 20 plus 34 upon root of x square minus 9x plus 20 dx. Individual integration, take the constants outside. And take 34 outside, it's a constant. So the left hand side, first integral is f dash x upon root f of x. Okay, because the derivative of x square minus 9x plus 20 is 2x minus 9. So it is f dash x upon 2 root f of x. So this will be 3 into 2 root f of x plus 34 I1. Okay, this part is I1 and this is I. Let this be equation number 3. Okay, so we'll solve this I1 separately. Fine. So your I1 is 1 upon root x square minus 9x plus 20 dx. Now there is a constant in the numerator and root of quadratic in the denominator. So we can do half into coefficient of x. So half into coefficient of x the whole square, half into minus 9 the whole square. Now negative square is always positive. So this is 9 by 2 the whole square. Negative sign will go within the bracket because it's square. So what we are going to do is we are going to add 9 by 2 the whole square before the last term and after the last term. So before the last term, we are going to add this, and after the last term, we are going to subtract this. Okay. Now the first three terms, x minus 9 by 2 the whole square and 20 minus 81 by 2. So that is 40 minus 81. That is minus 41 by 2. Okay. So this can be further written as I1 is equal to integration of 1 upon root of x minus 9 by 2 the whole square plus 41 by 2. Let me check whether it is plus or minus. Yeah, it's plus 41. Sorry, 40 minus 81 is minus 41 by 2 dx. So integration of root of x minus 9 by 2 the whole square minus root 41 by 2 the whole square dx. So this term is x and this term is a. 1 upon root of x square minus a square. Fine. So that is log mod x plus root of x square minus a square. That's the formula. 1 upon root x square minus a square. Fine. So x is x minus 9 by 2. And this should be C1 because we are solving I1, right? Minus a square is root 41 by 2 upon dy dx of x minus 9 by 2. So this will be log mod 2x minus 9 by 2 plus root of x square minus 9x plus 81 by 4 minus 41 by 4. Okay, so 81 minus 41 is 40. 40 upon 4 is, just a second, let me check. A is root 41 by 2. So this will be 41 by 4 x minus 9 by 2 the whole square. So x square plus 81 by 4 minus 9x. Okay, fine. So this will be 40 upon 4, the last two terms. That will be 10. Okay. So x square plus minus 9x plus 10 plus c1, which is equal to I1. So from one integration, sorry, from one, let us go to equation number one, 6 root f of x. So f of x is nothing but x square minus 9x plus 20. So 6 root x square minus 9x plus 20 plus 34 I1. See, we had a 34 over here. 34 I1. Now what's I1? I1 is this entire term. So I'll just write in the next line. So plus 34 log mod 2x minus 9 by 2. Okay. Plus x square minus 9x plus 10 plus c. This is the final answer. Just let me check. I'm not very sure about this 10. It should be 20. So somewhere I might have committed some error. So 20 minus 81 by 2. So that is minus 40 minus 81. Minus 41 by 2. Root 41 by. Oh, yeah. I got the mistake. This also will be root. Okay. Root 41 by root 2. Okay. So just a second. Just a second. No, it's minus 41 by 4 only. Correct. Minus 41 by 4. This cannot be root. This is 2. So 41 by 4. So that is 40 upon 4. One second. I1, let me check this I1 once again. Oh yes, this will be 81 by 4. Okay, this has to be 81 by 4. Okay, so this will be minus of 20 into 4, that is 80, minus 1 by 4. Uh, 1 by 4, so this will be 1 by 2 the whole square, right? Please excuse me for this. This is also 1 by 2 the whole square. So this will be 1 by 4. 81 minus 1, that is 80. 80 upon 4, that is 20. We got 20 now. Fine. So sorry for this. Okay, so take a look at I1 once again. Fine. So it is minus 1 by 4, which is 1 by 2 the whole square, x square minus a square. Simplification and then LCM over here. Fine. And then this is the last step. Okay, so that was the end of this particular problem. Let us take one more example. integration of x upon root 8 plus x minus x square dx. Linear term in the numerator, root of quadratic in the denominator. Let this be equation number 1. So linear a d by dx of quadratic plus b. So linear is x a d by dx of quadratic. Don't take root of quadratic, it's only quadratic. Plus b, x is equal to a into 1 minus 2x plus b. Immediately after the derivative, whatever step comes, that is step number 2. So x is equal to a minus 2ax plus b. Okay, underline the x terms. Now by comparing, 1 is equal to minus 2a. This implies a is equal to minus half, right? And these were the x terms. Now the non-x terms. There is no non-x term in the left-hand side, so non-x term is 0. And non-x terms in the left-hand side is a plus b. So b is equal to, or rather I should say a is equal to minus b. Or b is equal to minus a. From this a plus b equal to 0, so b equal to minus a. So a is minus half, so b will be half. Okay. Put the values of a and b in equation number 2. So from 2, x is equal to a is minus half 1 minus 2x plus b is half. Okay, now from 1, integration of, we got the value of x. Let's go to equation number 1, we got the value of x. So replace this x with whatever we got earlier, that is minus half 1 minus 2x plus half upon root of 8 plus x minus x square dx. Now split this into two integrals. Plus okay, now take the constants outside. Minus half 1 minus 2x 8 plus x minus x square dx plus half root of 8 plus x minus x square dx. So this is I. So I is equal to minus half. Now this part is f dash x upon root f of x. So that is 2 root f of x plus half I1. Now this part is I1. Don't take half in I1, okay? Half is separate. So this 2 and 2 is getting cancelled. So I is equal to minus root f of x. F of x is 8 plus x minus x square plus half I1. So this is equation number 3. Let us solve I1 separately. So I1 is equal to 1 upon 8 plus x minus x square dx. Fine. So first rearrange the terms. Minus x square plus x plus 8 dx. So root of, take minus sign common. Okay. First rearrange, put it in a proper order. Ax square plus bx plus c. Take minus sign common. Now the coefficient of x is minus 1. So half into minus 1 the whole square, which is 1 by 2 the whole square. Okay. Which is 1 by 2 the whole square. So add 1 by 2 the whole square before minus 8 and subtract it after minus 8. So I1 is equal to integration root of minus x square minus x plus 1 by 2 the whole square minus 8 minus 1 by 2 the whole square dx. Integration root x minus 1 by 2 the whole square, first three terms and the last two terms, minus 8 minus 1 by 4. Minus 8 minus 1 by 4 is minus 33 by 4 dx. Okay, so this will be, take this minus sign inside, so it will be 33 by 4 minus x minus half the whole square. So I1 1 upon root 33 by 2 the whole square minus x minus half the whole square. Fine. So this 33 by 4 I'm taking as root 33 by 2 the whole square. So this is a and this is x. So sine inverse x by, which equals, the formula is 1 upon root a square minus x square. So this equals sine inverse of x minus half upon root 33 by 2 plus c1, because this is I1, upon dy dx of x minus half. Dy dx of x minus half will be 1. Okay. And the value of this bracket will be 2x minus 1 upon 2 upon root 33 by 2, which is 2x minus 1 upon root 33. So this equal to sine inverse of 2x minus 1 upon root 33 plus c1. This is I1. Okay, now put the value of I1 in equation number 3. I'll show you equation number 3. This is 3. So from 3, I'm writing the last step over here itself. I is equal to minus 8 plus x minus x square plus half sine inverse of, I'm writing the value of I1. Sine inverse of 2x minus 1 upon root 33. Okay. 2x minus 1 upon root 33 plus c. This is the final answer of this particular question. Okay. Now, one last problem I'm going to discuss, but then it is not needed to solve it entirely. I'll just share first few steps. Okay. So the question is root of 5 minus x upon x minus 2. Now this category problems, what you have to do? You have to multiply and divide with the numerator itself. It's not rationalization, okay? It is absolutely not rationalization. But then same format problems, you have to multiply and divide with the numerator itself. So this will be 5x, 5 minus x into 5 minus x, the under root is 5 minus x, one term will come outside. Multiply the terms in the denominator, so that will be minus x square 5x plus 2x. So 5x plus 2x is 7x, and then minus 2 into 5, that is minus 10. So now this becomes linear upon root quadratic. You will solve this particular problem after this particular step. Okay. So remember, whenever the format is this, what we need to do. One problem just to, make you more clear about this. Root of 1 plus x upon x. So root के अंदर it is always linear upon linear. Okay. So multiply and divide with the numerator itself. So integration of 1 plus x upon x plus x square. So this is also linear upon root quadratic. Okay, so that way you can solve the entire problem. Fine. So this is the end of session number 2 on linear and quadratic equations expressions. Okay, session number 3 will be recorded soon. Thank you.